Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and now we are on to the topic distributions. So on the series, we have seen some case study on Poisson distribution and binomial distribution previously, and today we are going to see the case study on Poisson distribution as well. We have our AML students to perform the case study analysis on Poisson distribution. The students are Manasa and Yukesh.
I am Tinu Hirish. I am going to share a case study about applications of Poisson distribution. The Poisson distribution is used to model the number of times an event occurs in a fixed interval of time or space, given that the event happens independently and at a constant average rate. It is widely applied in various fields, including healthcare and medicine. Predicting the number of patients arriving at a hospital emergency room per hour, estimating the number of medical errors in a hospital over a month, business and customer service, counting the number of customers arriving at a service counter per hour, modeling call center traffic and transportation, estimating the number of accidents at a particular intersection in a day, predicting the number of buses arriving at a stop in a given time period.
To tell the real-time application of Poisson distribution. So first one, modeling website visitors per hour using Poisson distribution. So website traffic fluctuates throughout the day, with some hours experiencing more visitors than others. So understanding these patterns is crucial for website owners, digital marketers and IT teams managing server performance. So the Poisson distribution is a probability model used to describe the occurrence of events in a fixed period, assuming they happen randomly and independently. In the case of website visitor, it helps predict how many users will visit a website in an hour given a known average rate. So for example, if a website typically receives 500 visitors per hour, this model helps estimate the likelihood of receiving 450, 500 or 550 visitors in any given hour. So why we are using Poisson distribution for web analytics is predicting traffic trends. So website owners can anticipate traffic patterns and plan resources accordingly. So knowing the expected variation in visitors helps in capacity planning for servers and bandwidth. Server load management. So websites need to handle peak loads efficiently. So if a website usually gets 200 visitors per hour, Poisson modeling can predict how often visitors count exceed 250 or drop below 150. Marketing and campaign analysis. So businesses running online ads or promotions can estimate traffic surges. Anomaly detections. So if the actual visitor count is significantly higher or lower than the predicted range, it could indicate an unexpected trend or a cyber attack. So real world application. So imagining an e-commerce website that typically receives 1000 visitors per hour during regular days. So during a sale, they might get higher traffic, but by using the Poisson distribution, they can estimate how much variation to expect. Thank you.
So hi everyone, myself Yukesh. So today we are going to discuss a topic about Poisson distribution case study. So I came up with the real-time examples, formulas and case study. So the scenario is telecommunication companies operates a call center where a number of customers calls arrive following a random pattern. So the company wants to ensure it has enough staff to handle incoming calls without execution. So a telecommunication companies has trouble to manage a number of calls and giving. So we came up with an application in Poisson distribution. So the Poisson distribution is used to the model number of call array in a fixed time period. So if an average number of calls per minute knowing, so let's have an example like if a 10 calls per minute, the Poisson distribution helps to predict likelihood of receiving a specific number of calls in a given frame. So we have some use cases. For example, to estimate the probability of receiving more than is a call in a minute. So determine the minimum number of agents required to keep an average wait time. So optimizing the satisfying duration cost, T cost based on call array. So they represent a formula. So if an X represents the number of calls receiving in a minute, and the average number of calls, summation of 10 weeks, they have been using this formula to predict the value of the. So the final outcome will be the company can use this Poisson model to avoid understaffing, leading the customer dissatisfaction, and overstaffing in the month. So thank you.
So under Poisson distribution, Manasa has explained some of the real-time applications and case study on Poisson distribution, wherein she has given some points regarding predicting traffic trends, server load management, marketing and campaign analysis, and anomaly detection. So these are the key points noted by Manasa and Yukesh, wherein the binomial distribution has been transformed to Poisson distribution when n tends to infinity and the parameter goes to an infinitely large number. Therefore, we arrive at Poisson distribution from the binomial distribution, where the differences between the two are, in Poisson distribution, we will have no successes or no failures. Only thing is we will have all the rates to be infinitely large. But in binomial distribution, we will have the success rate and the failure rate as a value there, so that this is the major difference between the binomial distribution and the Poisson distribution. This is how we have performed the case study using students on Poisson distribution and binomial distribution. Thank you.